Hey everyone, and welcome to today's Explainer. We are jumping right into a comprehensive industry masterclass on MEP drafting and BIM systems. Whether you're a mechanical, civil, or electrical engineering student, a facility management trainee, or a BIM professional aiming to bridge the gap into EPC project coordination, consider this your foundational boot camp. We're going to map out the entire specialization pathway for designing, drafting, and managing the critical systems that bring modern architecture to life. Okay, let's dive into this. You know, it's a staggering statistic, but according to industry research, there is often a massive disparity between how a building is designed to perform and how it actually operates in the real world. This is known in the industry as the performance gap. And it doesn't just happen by accident. It's primarily caused by a lack of proper understanding of building design, really poor detailing, and a failure to coordinate how different components interact before the concrete is even poured. Closing this gap requires a highly specialized set of skills and a modern digital workflow.
To get you industry ready, here is our syllabus for today's bootcamp. We're going to build our knowledge step by step. 1. Building services fundamentals. 2. The power of BIM. 3. AutoCAD and MEP drafting. 4. Revit modeling and design. And finally, 5. Coordination and clash detection. Let's get right to it.
Module 1. What are building services? Before we can start modeling or drafting anything, we really need to establish our baseline foundation.
You're going to hear the acronym MEP constantly in this field. It stands for mechanical, electrical, and plumbing. Collectively, these are the building services. They're basically the lungs, the veins, and the nervous system of any facility. Without them, a building is literally just a concrete shell. And to put the sheer scale of this into perspective, in any new construction project, MEP services typically account for 30 to 40% of the total project budget. Because the financial stakes are just that massive, the engineering absolutely has to be flawless.
When we break MEP down, we're really looking at highly complex, interdependent networks. You've got HVAC for climate control, intricate water and drainage networks, the entire lighting and power supply grid, and absolutely crucial fire safety systems. Designing all of these requires crazy levels of precision. Think about it. If you miscalculate the spatial requirements for a giant ventilation duct, you might physically crash it right into a plumbing riser out on the construction site. And trust me, that means massive delays, blown budgets, and a lot of angry contractors.
Moving right along to Module 2, the power of BIM. This introduces the modern, global solution to that performance gap we talked about earlier.
And this brilliantly illustrates exactly why this leap in our industry is so revolutionary. For years, we relied on standard 3D CAD, which focuses purely on geometric expressions. It just shows you what a shape looks like. BIM, on the other hand, goes way beyond geometry. It captures the relationships, metadata, and intrinsic real-world behaviors of components. A digital pipe in a BIM model actually knows what material it is, what kind of fluid it's carrying, and how much pressure it can withstand. It's incredibly smart. Let's lay down a clear definition. Building information modeling. Now here's a sticking point that trips up a lot of novices. BIM is not just a piece of software. It is a completely holistic, collaborative methodology. It's an entire process for creating and managing structured, multidisciplinary data across an asset's entire life cycle, from the very first design sketch all the way through to facility operations. It really is the gold standard for global engineering certification. Module 3. AutoCAD and MEP drafting. Now, while BIM is the overarching process, traditional 2D drafting remains an absolute foundational skill, and AutoCAD is still an industry workhorse. If you're stepping into a role as an EPC project engineer, handling engineering, procurement, and construction, this is the actual practical workflow you'll execute day to day on the job. You'll usually start by laying down precise 2D layouts in AutoCAD. Next, you take those flat designs and elevate them into intelligent 3D models using Revit. And finally, you pull those multidisciplinary models into Navisworks to run clash detection. Mastering this specific pipeline, that is your key to landing a great industrial job.
During that initial AutoCAD phase, your focus is purely on geometric groundwork. For HVAC, you're mapping out duct layouts and unit diffusers. For electrical, it's all about single-line diagrams and lighting grids. For plumbing, you're looking at water supply lines and riser diagrams. But here's the absolutely most critical part of this syllabus step. You must stick to strict international drafting standards. You have to use the exact right layers and standard engineering symbols so that anybody, anywhere in the world can flawlessly read your shop drawings. Which brings us to Module 4, Revit Modeling and Design. Once that 2D drafting is set, this is where those flat layouts evolve into living, breathing 3D intelligence.
So the crucial point is really understanding the distinction between the BIM process and the Revit software. Like we just established, BIM is the overarching methodology. It's the way project teams collaborate and manage information. Revit is simply the software platform created by Autodesk that is specifically designed to facilitate that BIM process. It's the digital tool where all that structured, intelligent data is actually stored and manipulated. The Revit MEP workflow is an absolute powerhouse. You aren't just sketching lines anymore, you're modeling actual physical HVAC equipment, air terminals, electrical cable trays, and incredibly complex pipe routes. But the true superpower of Revit is work sharing. By using central files, the architect, the structural engineer, and the MEP design team can literally all collaborate inside the exact same digital model simultaneously. Plus, you'll learn to create parametric Revit families, meaning you can design custom components that automatically adjust their own dimensions based on the rules you set up.
Though remember, Revit isn't just for making pretty 3D visuals. It is a heavy-duty calculation engine for vital engineering metrics. For HVAC, it's crunching psychometry and heat load calculations to figure out exactly how much cooling a space actually needs. For plumbing, it's doing sanitary and drainage pipe sizing. For the electrical guys, it handles load estimation and builds out panel schedules. And it even aids in precise fire protection and sprinkler system design. You are literally engineering the building's performance virtually.
Now, why is all this intense, precise calculation so absolutely necessary? Well, it comes down to the codes. Take fire protection, for example. Your systems have to adhere to over 300 different codes and standards from organizations like the NFPA. And these aren't just dusty old rulebooks. They're updated every 3 to 5 years by thousands of experts to reflect changing safety technologies. In this industry, compliance isn't just a nice-to-have, it is literally the core of the job.
Module 5, Coordination and Clash Detection. You have your architectural model, your structural model, and your incredibly detailed MEP models. Now we have to make sure they all actually fit together in reality.
Let's move to and see how this builds into the final phase of a project lifecycle. You take your various inputs, those architectural, structural, and detailed MEP models, and you feed the whole shebang into processing software like Autodesk Navisworks. This acts as your ultimate multidisciplinary arena. And what you get out of it isn't just a cool 3D view, it outputs highly accurate construction documentation, complete with schedules, and flawless sheet plotting that's ready to hand over to the site contractors.
The absolute star feature of Navisworks is class detection, digitally identifying physical intersections between your building surfaces. If an electrical cable tray is modeled going right through a structural steel beam, Navisworks highlights it instantly. Discovering a digital pipe crashing into a digital duct saves thousands of dollars and keeps the whole project on schedule. And let's be real, that is infinitely better than discovering that same exact clash with a physical steel pipe out on the job site.
And that wraps up our Masterclass Explainer. We've covered how MEP systems are the true lifeblood of any building, how BIM completely revolutionizes team collaboration, and how tools like AutoCAD, Revit, and Navisworks combine to create a flawless digital-to-physical workflow. The industry right now is desperate for professionals who can navigate this ecosystem and close that performance gap. The methodology works, the tools are here, so the only question left is, are you ready to master MEP systems and engineer the sustainable digital buildings of tomorrow? Keep learning, and we'll see you in the next explainer.